Good morning, everyone. Welcome to our lesson today. Our lesson today will be on answering the question that I gave under cut number 3. In that cut number 3, we had the problem stated as follows. As an engineer, design a channel that allows water to flow full in an asphalt half hexagon channel of bottom width W. The flow rate is 12 cubic meters per second, so estimate W if the Froude number is exactly 0.6. The question was 5 marks. So the solution goes as follows. The shape of the channel is half hexagon, and an hexagon from this figure, an hexagon has 6 sides, as you can see in that figure 1. The material that has been used to construct this half hexagon channel is asphalt. So now when we are at this point, we need to ask ourselves which equations are we going to use. So the first equation that I've been teaching in class is the equation of continuity. The continuity equation states that Q is constant. That is, area times velocity is constant at every point. That equation Q is equal to AB is given equation number 1, where Q is the discharge in cubic meters per second, V is the velocity in meters per second, and A is the area in square meters. The other equation that we are going to use in this problem is the Froude number equation. The Froude number equation is given by V divided by the square root of the product of acceleration due to gravity and y. Y is the length. And since we are dealing with a trapezoidal kind of shape based on the half hexagon, it means we are going to use the equation of the generalized format of the Froude number, whereby y is given as a over b. So in this equation 2, we find that Fr is the Froude number, v is the velocity in meters per second, g is the acceleration due to gravity given by meter per second squared, and y is the hydraulic depth given by area divided by top width. So we need to draw the half hexagon, which is a trapezium, as follows. In that hexagon, we have values W, the sides are W, and then the bottom width is also W. So for us to find the area, we have to determine the height. So what is the height of that trapezium? So the height of that trapezium, we use the trigonometrical ratios. So we shall use the trigonometrical ratios. But before using that, so let us find first the top width. So for us to find the top width, which is B, is going to be given by W plus twice X. And what is X? X, using the trigonometrical ratios, we shall say X divided by W gives us sine 30 degrees. You remember that when you have hexagonal shape, all the external angles add up to 360. Since we have 6 sides, so we say 360 divided by 6 sides. So each external angle is equal to 60. So meaning that this place becomes equal to 30 degrees. Then the next item that we want to find is that since we find that x over w is equal to sine 30, so x is equal to 0.5 w. Therefore, b will be w times twice x, which is twice 0.5 w, giving us 2 w. To find the height, we use also the trigonometrical ratios. Here we use the trigonometrical ratios there. So height over w is equal to cos 30. Therefore, the height of that shape is given by 0.866 w when you find the cosine of 30. So the area of trapezium is given by area is equal to half top width plus bottom width multiplied by the height. So when you bring in the top width being 2W, the bottom width W, that gives us 3W, and then we know the height is 0.866W. When you do that maths, you find that A is going to be given by, area will be given by 1.3W squared. So that is the area. So let us find the hydraulic depth. Hydraulic depth is given by area over B. So which is 1.3 W squared divided by 2W, which gives us 0.6 W. From the Froude number, we are given that the Froude number is exactly 0.6. So we substitute the value of Y, and the Y is A over B there. So after substituting, we find that the velocity is given by 1.515 square root of W. So going back to our continuity equation, we can write Q in terms of W. So Q is equal to AV, which is equal to area is 1.3 W squared times 1.515 W raised to half. Root of W is the same as W raised to half. And once you do that math, you find that Q is given by 1.9696 W raised to 5 over 2. Since we are given that Q is 12, so we just have the equation given like that. 12 is equal to 1.9696 W raised to 5 over 2. To solve this kind of equation, I've been saying let us use what we call trial and error method. So let us try with W and see which value. Let us try with W equal to 1, and we continue increasing or reducing until we find the right hand side of the equation, that is 1.9696 W raised to 5 over 2, giving us 12. So when we started with 1, so 1.9691 times raised to 5 over 2 gives us the same value, 1.9696. Let's try 2. So when we try 2, we find that we find 11.14 once we put 2 raised to 5 over W like that. So it means we are almost close to 12. So let us try 2.1. When we use 2.1, it went beyond 12. So now we come down and we substituted using the value of W being equal to 2.06. When you put in the value of 2.06 as the value of W, you will find that the right hand side becomes 12, and therefore W equal to 2.06 meters. And that is the value of the W that is required to carry a flow of 12 cubic meters per second, and the flow having a Froude number of equal to 0.6. Thank you and welcome again in our next lesson. Bye for now.